Hello guys, Assalamu alaikum. Uh, I have this question. Of course, first I introduce you. My name is Isa Khaldi, and this is question 5 in Fluid Power Fundamentals, lecture 7, which is about controlling volume analysis. So this question says, firefighters are holding a nozzle at the end of a hose while trying to extinguish a fire. If the nozzle exit diameter is 8 centimeter and the water flow rate is 12 cubic meter per minute, determine A, the average water exit velocity, and B, the horizontal resistance force required of the firefighters to hold the nozzle. So first, we always use the meter, the second, so we have to convert the minute. So we have the volume flow rate, V dot equal, let's use another color, okay, and let me specify the thickness. Okay, that's good. Okay, V dot equal 12 cubic meter per minute. So in 1 minute there is 60 seconds. So it will be, if you calculate it in your calculator, it should give you, let me calculate it now, because I think I haven't calculated this. So this is going to be 12 divided by 60 is going to give you 0.2. Okay, of course it's going to be cubic meter per second. So that's the first thing. The second thing, we notice that he already has given me, oh sorry, okay, so you can notice that he has given me the exit diameter, which is 8 centimeter. Whenever you see D, the diameter, you always think of finding the area. So first we have 8 centimeter. You know, the D, the diameter of the exit, is 0.08 meter. You have first to convert it to meter, then you find the area, which is pi times 0.08 square divided by 4. Let me calculate it now, because I think it's going to give me 5.026 times 10 to the power minus 3 meter square. So I'm done now with the area. Okay, so now if I have the area and I have the volume flow rate, why don't I find the velocity? Because the velocity will give me V dot divided by the area. So we have the V dot, we have the area, so let's compute. V dot, which is 0.2, divided by the area, which is 5.026 times 10 to the power minus 3, and this is going to give you 39.8 meter per second. So you have to follow these steps to answer the problem. Okay, so now let me just sketch some drawing for the here for the problem. So they have a hose. It looks like that. Okay, it looks like that. This is the water coming out. I have here the FRX. Here I'll call it 2. Here I would call it 1. Okay, and here is the water coming out. Okay, so now we also have the m dot equal rho times v dot, right? Because m equal rho v, so m dot equal rho v dot. So this is going to give me we always assume, we don't know exactly, but we always assume that the density of the water is 1000 multiplied by the volume flow rate, which is 0.2, and of course the m dot will give you 200 kilogram per second. Okay, so we found the mass flow rate. So we also found the average water exit velocity. Now we need to find the horizontal resistance force required for firefighters to hold the nozzle. So let's we have already drawn the free body diagram, or whatever you call it. It's very simple, but yeah. Now let's of course, here you can see that let me just, oh my god, try to remove this. Okay, yeah. Okay, so yeah, so now the water is going in the x direction, so we don't have anything in y. So we would say sigma fx equal sigma out beta m dot v minus sigma n beta m dot v. This law from chapter 6, Bernoulli's law. So there is nothing actually much we are doing, just computing very straightforward question. So frx, oh just excuse me, okay, frx equal the look, if the question, just let me write it here. If beta was not if beta was, just let me write like that, yeah. So if beta was not given, you assume 1, so beta equal to 1. That's just, beta is approximately 1, so we say 1 times the m dot, which we found now 200, times the v, the exit velocity, which is 39.8, and then minus n. Is there anything going in? No, so it's 0. So yeah, F Rx is equal to 79 60 Newton, 7,960 Newton. And that's our question. We are done.